All right, so now you've done number 4. You've gotten answers for all of these. Here they are if you want to check your work and what the intervals are. I did want to show you one thing. I think I can do this at this point. Yeah. When you go from 25.5 to 25.05, I want to show you another nifty thing in your calculator. So let's say I hadn't done, the 25.05 yet, and I had just done the 25.5 interval. So I had just done this one. All right. So then I go to copy it down, right? So my problem is I want to put in 25.05, but the TI is sort of always in type over mode. So if I put here and I start putting 05, it's going to cover up all my work and I'm going to put the Y1 again. So I lose the advantage of copying it. So if you didn't know this, another important thing that TI can do is you can do an insert mode. So you have delete right there, and above it says insert. So you go second, insert, and now I can put in the 0 and the 5 just slides over. So that's what you have to do when you're doing a copy and paste and you want to put in a longer set of digits. So this is 24.5. I want 24.95. If I just put 95, it won't be so bad here because it's just the end of the expression anyway. But back here, I would have to retype the whole thing. So what I do is go second, insert, and I'm doing 95 here. Yeah, 24.95. So I just put the 9 there, yep. And then I go down here. I could do the same thing here to get my 0.1, but it's easier in this case just to type 0.1 because it's not part of a long string of syntax. So it's not as important. But I just want to show you that second insert if you have a long string and you want to put something in the middle of it without having to type everything over. And so that gives me that number, which I have here. All right, and so you're going to use these numbers to fill in this chart. Make sure you include, the intervals and everything. Now, it says, do the values in the table appear to approach a definite value? So as I use shorter and shorter intervals, and again, this is what this is about, I have intervals all centered at 25, but they're getting shorter and shorter. So I'm using 5 seconds, 1 second, 1/10 of 1 second, 1/100th of a second. I'm using shorter and shorter time intervals. What do I get for velocities? Negative 2310, negative 2223. It's a pretty big jump, of like 90 meters per second. Then negative 2201. I notice these two are closer together. Then negative 2194, 93. 0.7529, 93.7500. So these numbers are sort of settling in to a value, and it looks like they're approaching negative 2193.75. So yes, the velocity, I keep saying speed up here, it's really velocity because it's negative. Velocity is approaching, and this word approaching is going to be really important to us, getting closer and closer to. We actually have a mathematical definition for what closer and closer means. Velocity is approaching negative 2193.75 meters per second. All right, so now, starting in number 6 of this investigation, we want to look at even smaller intervals. So now we're going to go down to intervals of much smaller. So we went down to 1/100th. 1/100th of a, is that 1/1000th of a second? It's 1/100th of a second split in 2. Okay, so 2, 5, blah, blah, blah. It's 100th of a second. We want to do a 1,000th of a second, 10,000th of a second, a millionth of a second, a billionth of a second. All right, because that's the trend that seems to be leading me toward a defined value for what this would be at the instant of 25 seconds. So in order to do that, we're going to simplify the work so that I don't have to keep finding y of 2 different values and subtracting and dividing. What I want is one equation that I can just put in the delta t and get out the speed for that delta t. So it's a lot of work to get that equation, but once I get that equation, it simplifies the work. And it will also allow us to apply what we get as a result to many different situations, to apply the process to many different situations. So the first thing I did was throw a monkey wrench in the works by changing the meaning of delta t. So now we're going to observe that the speed is always given by, this is why I wrote this way, r of delta t. It's y of b minus y of a over b minus a, y of b minus y of b minus a. That's what the r is. And I'm going to say that r only depends on delta t, because the delta t will determine what the values for y1 and y2 are. So that's what we want to try to simplify. So here's what's the shift that I'm making for convenience. I've been calling this entire distance, the length of the interval, I've been calling delta t this whole time. And that's sort of the standard thing to do. But for the work that follows, we're going to have to always deal with delta t over 2, and it's going to be a pain. So I'm redefining what delta t is. So the new delta t is just half of the time interval. We're going to call this delta t now. All right, so we're going to define delta t as half the length of the time interval from now on. Okay, and delta is often used for a change. So then you can see how the interval from A to B, so this is like A and B of each interval. This is the A, the B here, and the A here, B minus A, B. All right? That A is going to be 25 minus delta t, and the B is going to be 25 plus delta t. Right? So if I took the old definition of delta t and used this one we were calling delta t equals 5, then I would have to go 25 minus half of delta t and 25 plus half of delta t. So in order to avoid that, I'm going to say, okay, for this first one, the delta t is really 2.5. That way I can just call it 25 minus delta t here, 25 plus delta t here. Okay, so there you go. Now, we're saying in the expression for r of delta t, substitute the expressions for a and b, these expressions, in terms of delta t. So if you haven't done that yet, you should do that now, and then see if it compares to what I get.